before we get started on Venn diagrams, we're going to do a little bit of review on the stuff we learned yesterday, because we're going to need to know how to do this kind of stuff if we're going to be able to do Venn diagrams. Right? So yesterday and the day before, we talked about sets, and we learned symbols that go with sets, all kinds of fun stuff. So we're going to do just a review practice question. It says, consider the following subsets within the universal set of numbers less than 20. So they give you the universal set. So that means there's a third set. There's the universal set, plus there's set A, and plus there's set B. In the universal set, what do we have? All numbers less than 20, including 0. It doesn't say natural. So we're going to assume 0 is And remember, I like to write them all out because I feel it helps me stay organized once things start getting a little complex. Ooh, that's a lot of numbers. Just gonna move it up. There we go. There's our universal set. 0 all the way through to 20. Set A is going to be numbers less than 20 that are divisible by 5. So which numbers are less than 20 and divisible by 5, you would? 5, 10, 15. So I like to write them out because it just makes my life easier instead of trying to do everything in words. Part B says numbers less than 20 that are divisible by 3. What numbers are less than 20 that are divisible by 3? 3, 6, 9, 12, 15, 8. Alright, as I'm reading the question, I'm writing out my sets. Makes life easy. And then I can actually start to get into the questions. So it says list the set of numbers that are less than 20 and are in. And there's 4 questions here. So the first one, you have to list all the things that are in set A. That one's easy, we've already done it. The things in set A are 5, 10, 50. That's all the things that are inside A. B. All the things in set B. That's easy too because we've already written that out. So what's all the things in set B? 3, 6, 9, 12, 15, 8. C and D are where things actually start to get a little interesting because we need to remember what things are asking us. So if you go to read question C, those symbols mean something. When you read it, it's saying all the things that are in set A and set B. Remember, the upside down thing means and. So that's going to be only things that are found in both set A and B. What things are found in set A and set B? 15. So that's going to be the only thing in set A and B. So that little upside down symbol, that means D says all things that are in set A or B. So that one where it's facing up, like a little horseshoe, is or. And or means you want to include everything in A, everything in B, and anything that's in both A and B. In our case, that means we would have all these things in B, 3, 6, 9, 12, 15, 18, and you would also have to add into it 5 and 10, because they aren't in set B, but they were in set A. 15 was already included in set B, so we don't have to write it twice. So our answer to A or B would be 3 that means A or B. Simple? Remember it from yesterday? Yeah. Awesome. Now, sometimes writing out all those lists can be a little bit of a pain, and there's actually ways you could represent those things in picture form. So our first question here is going to be, how can we represent the last example in picture form? We call that a Venn diagram, and that's what I'm going to show you how to do. You've probably seen them before. And if you haven't, that's okay. You don't need to have seen them before. A Venn diagram always starts off with a big square. The reason it always starts off with a big square is that square represents the universal set. That's all the things that aren't in the other subsets we're talking about. So this big square is the universal set. Each subset is then a circle inside of the universal set. So I'm going to do a big circle for A. That's actually not a bad circle. Yeah, you should be pretty impressed, because my next one's going to be more accurate to my drawing ability. And then I'm going to do a big circle for B. Also not that bad. Sort of close. It got a little crazy here. I'm going to label these set B, set A. They're also in different colors to make them nice and clear to you that I'm talking about. Green is A and blue is B. Okay. Within these bubbles, so all the things in set A, I'm going to write in the bubble for set A. And all the things in set B, I'm going to write in the bubble for set B. So in set A, we had 5, 10, and 15. So in A, I'm going to put 5, 10, and 15. In set B, I'm going to put all the things that were in set B. So we had 3, 6, 9, 12, 15, and 18. Remember that these bubbles are part of the universal set, right? So I'm saying any of these things in these bubbles are part of the universal set. And if I look at this, that means right now the universal set has 15 twice. And that doesn't make sense. We would never write something out twice like that, would we? So 15 would go in the middle, right here, where these two bubbles intersect each other. That's the number of things that are in set A and set B go in that middle portion. They don't go here. So because 15's in both sets, you make sure that it's in the spot where they overlap each other. That says 15 is in both sets. Yeah, and as you get good at these, you probably will just know 15 goes right in the middle, and you won't even have to worry about that. There's still a whole bunch of things we're missing. Because if you think about the universal set, it included all of these numbers up top. So that means all those numbers have to be somewhere in our universal set. So anything that wasn't in A or B should be around the outside, filling in the gap around the outside. So numbers we missed, 0. You don't need to put commas on it. 0, 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, and 19. Those are things that were still in the universal set, but they weren't in either of our subsets A or subset B. You could put them straight in a line. You could have written them all across the top. You could have done anything you want. As long as they're outside the bubbles, it doesn't matter where they are. And same with the things I wrote in the bubbles. It doesn't matter how you wrote them. I wrote them in what I felt was an organized manner, but you could have put them in any way you wanted, and it's still going to be right. No, because it said less than 20, I think, right? Was 20 in my original universal set? It was, but it shouldn't have been. Less than 20, so it should have included 20. Spell those. This picture is an example of a Venn diagram. And Venn diagrams are very good, very useful for reading data and understanding data. For instance, if I looked at this picture right now, and I said, what's in set A and set B? It's pretty easy to look at that and go, 15 is the only thing in A and B. And you don't have to go searching through lists to try to figure it out. Because that's the only thing that's in both circles. Does that make sense? See the use of it, right? Alright, we're going to do some shading, and we're going to also discuss things in words as a way to remind ourselves what things are. So, in words, represent what each set means, and then shade the region that represents that set. Question A. This means set A and B. So this means things in set A and B. If I was going to shade that region in, it would be right here. Anything that's in that little portion that I've shaded would be what belongs to A and B. B says anything that's in set A or B. So I'm going to write that on words. Things in set A or B. So if I was going to shade that in, I would shade in everything that's in the bubble A and anything that's in the bubble B. And you'll see it includes where they overlap. Question C. We haven't seen that yet today. This thing? This thing records my voice, and it can see the voice. But it doesn't see it. Like, this is just a mic. My computer records the voice. Of course, it has solid. Yeah, it's pretty awesome. When you listen to a video, it'll be like delayed by like 20 seconds. No big deal. It's very high tech.
We'll also be able to hear you saying that, right?
Yeah, now they're gonna watch this video and be like, "You're wasting my time right now." Okay. What does this apostrophe mean? This thing right here. It means not in it, right? So this would be things, blue, not in set A. Things not in set A would include all of this. So all those things that are in B but don't overlap with A. And it would also include all of this. That's all the things not in set A. So you would read whatever's in the brackets. So if it was like A and B, then you'd be looking for all the things not in A and B. So that'd be, yeah, all the things not in A and not in B, and then not in that. Yeah, it's possible. We do some big ones today. So you'll see. Yeah, in your practice? Yeah. It means like not, and then not that. So it's like triple canceling. We'll go over it together. Makes it easier. It's hard to talk about when it's that big. All right. For each example, represent the set in words, shade the region of the Venn diagram, and list the members that are in that set. So, for number 1, it wants to know all of the things that are in set A. So, all things in A. That's what that means in words. In the Venn diagram, what does that mean? It would be bubble A. So it would be anything in this shaded region. So if you were to list the members of all things in set A, you would be listing 3, 6, 9, 12, 15, and 8. That's all the things in set A. See how a Venn diagram can kind of be nice to like picture something and just see it? And as the things get bigger, it's actually kind of nice to be able to do them. And it's nice to be able to shade. That's why I'm making you shade things in. Because as they get more and more complicated, the shading is going to become beneficial. Especially with a pencil, or if you have 2 colored pens or 2 highlighters or something like that, it can become very useful. All right, number 2, give it a shot on your own. So describe it in words, list all the members, shade the region. So if we look at that, it says all things in set B. That's how I describe it in words. If I was to list out all the things in set B, I would list out 5, 10, and 15. If I was to shade it, I'm shading the entire circle B.
Even the 15 because it counts in both.
Even the 15 because it counts in both. Yeah, it's part of set B as well. And I definitely tried to like draw around it. All right, question 3. That says all things in A and B. That means things that overlap each other, right? Things that are in both A and B. The only thing that's in there is 15. That's the only item that's in A and it's in B. Think we got a hold on this? Yeah? Okay, the next page has 3 more. I want you to go through them on your own. Rip through them. There is a not in there, so that makes it a little harder. There's also an or in there, which I haven't done yet. But try to describe it in words, write out the set, and then shade it in. And I'll do the same thing on the board. Okay, so the first one was all things in set B. The things in set B were 5, 10, and 15. I colored them in as this red circle here. It's anything in that big circle. For question 2, it was all things not in B. So that means that B circle should be completely left alone and everything around it should be shaded. My shading sucks because if I color over a number, then I can't see the number. So I just kind of scribble in between as much as I can for you. But you guys, if you shaded it, hopefully it was pretty shaded compared to mine. But you should have noticed that the circle around B, this thing, was completely untouched. The third one was A or B, so that means you could circle everything in A and everything in B, and you'd end up with this weird look at the double circle all colored in. And that's numbers 3, 5, 6, 9, 10, 12, 15, and 18. I had a good question, and it was, does it matter how you list things? It really doesn't at the end of the day. So if you didn't list it in the order of 5, 10, 15, maybe you would have 15, 10, 5, that's fine. As long as all things are in the brackets, you're good. I think that I just like the order when it's going up. But you can write it in any way you want. All right. 3 more. And they're starting to get a little bit harder now. So I'm going to do number 1 with you, and I'll leave you for 2 and 3 to try on your own and see how you do. So number 1, if I'm going to read that as a sentence, it would be all things not in A and are in B. Gotta write that up. All things that are not in A and are in B. So if you're looking at this diagram, I'm going to shade in green all the things that are not in A. Okay, so all the things that are not A looks like this. And this is where multiple highlighters might come in handy, or maybe some pencil crayons. Okay, so in green is all the things not in A. In blue are all the things that are in B. So if you shaded this with 2 different colors, you're looking for the things that are in the green and are in the blue. So what section would be in the green and the blue? It would be this section here. It's hard to tell, but it would be that portion. It would be that stuff that's in B, but it's just not including that intersection with it.
So can you just
Pardon? Yeah, like if I were you guys, I would definitely invest in like maybe 2 highlighters or 3 highlighters or 2 pencil crayons or 3 pencil crayons, and then bring them. And it's easy to shade and be like, where are things overlapping? Because in this case, when it says and, this right here, that's talking about where they overlap. So I'm only trying to figure out where the shaded regions overlap. I'm just going to undo those drawings so that you can see what I'm talking about again. There you go. So the only numbers that were in that overlapped red region would have been 5 and 10. That was the things that are not in A and are in B. 15 wouldn't count because 15 is in B, but it's also in A, and we want to be not in A. Any questions about on? Okay, I'm going to let you try number 2 and number 3 on your own. So give it a shot, see if you can figure it out. It's tough. 3 is definitely kind of confusing as well, but give it a shot. And I'll talk it through either way at the end. Alright, if we look at B, we want to shade in all the things that are not in A and are not in B. So in the red, I have shaded all things that are not in A. So I shaded the entire outside plus the part of B that didn't intersect. In green, I colored in all things that are not in B. So I colored the entire outside plus the part of A that didn't touch B. And because I'm doing an and symbol, I want to figure out where those things intersect each other, where the green and the blue are intersecting each other. That happens to be the entire outside. So I listed all the things that were outside the 2 bubbles. The numbers were 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, and 19. Alright, number 3. The reason I didn't shade it into is because I think if I shade that thing in right now, it's going to be way too confusing if you just look at it. So I'm going to shade it with you guys as we go. If I were to read it, I would want the things, this is a confusing one right up. Things that are not in A and B. So the things that are not in A and B. So my job is to figure out what's inside the brackets first. So I'm going to take A and B, and I'm going to shade that region. A is this entire thing in red. B is this entire thing in blue. So where would A and B be? A and B would be this middle portion where they overlap each other. The number 15. You want to be not in A and B. So that means that thing you shaded in, that's the only thing that you don't want to be. So you want to be everything else around the outside. So if I was to take away my colors, that means this portion is the only portion I can't include. I want to include everything else outside. It's almost like you shaded everything in, and then when it says not, now instead of looking for the shaded region, you're looking for the unshaded region. So the list of things for that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, and 19. That's all the things but 15. Does anyone have any questions about any of those two? Clear as mud? Okay. Alright, you got 3 more. Don't worry about writing out the sentence for them. See if you can just list the things. If you need to write the sentence to help you, do that. If you need to shade it in, do that. But I want you to try to just figure out what's in these sets. So this first one is things that are in A or not in B. So go ahead and see if you can figure that out, however you need to do it. I'm going to list them up here, and then we'll talk about that. So the first question was things that are in A or not in B. So if you were to shade this out, I'm looking for things in A. And shade in everything in A. And it says, or not in B. So in red, I'm going to shade in everything that's not in B. Alright. When we use the symbol and, we were talking about where the two colors intersected each other. When we're talking about the word or, we just care about anywhere that there's color. So anything that I've colored in counts as part of this subset. Yeah. It would be part of B, but it was part of A. So it'd be anything in A or anything not in B. So I included 15 because it was or. If it had been and, then I wouldn't include 15. That answer the question about or? So if you're shading, it's anything that the shading is touching is what or means. Alright, keep going. Alright. Let's talk about a couple of these. So if I'm looking at number 2, that says all the things that are not in A or the things that are not in B. So what I did is I went and I shaded all the things not in A, and I did that in red. So in red all the way around the outside, I circled all the things that are not in A. Then I went in green and I circled or shaded all the things that are not in B. So I shaded all the way around. I even shaded a little bit of B because so in green I shaded all the things not in B. Because it's an OR statement, I want to include anything that I have shaded. So my list of things would be anything shaded. The only thing that ended up not shaded was 15. Because 15 was in A, 15 was in B. And I wanted the things not in A and the things not in B. That's the only thing that's in both. Coincidentally, remember when you were talking yesterday about equivalent things? That means that not A or not B is like the same thing as talking about the opposite of just what's inside of A and B. So that's a cool little thing. It's do the same thing as saying A and B, but not really. So those are actually equivalent things. Not that you need to know that. Yeah. On the paper? Yeah, let's do one second. For number 3, this one's a little trickier. So I looked inside the brackets first and I started shading. They wanted to know the things in A, so I circled anything in A using blue. That was that entire circle. Then in green, they wanted to know all the things in B. So I circled everything in B. That means anything I touch would be in these 2 circles. But they didn't want anything in A or B. They wanted not anything that I've shaded. So it's the entire outside that I'm actually looking for. So I shaded everything in that they wanted for the brackets. And then because there's an apostrophe outside the brackets, they are saying we don't want that. So it's everything that I didn't shade. That's by far, I think, the most confusing. You get it?
I got that one. I got a song sheet.
Yeah. I shaded in what I want on the brackets, and then I go what's not shaded in once I see that not symbol. All right, any questions about reading Venn diagrams? All right. Why Venn diagrams are useful? So, Venn diagrams are also a good way of sorting information. In this question, the Venn diagram represents the number of students who like soccer, so that's group S, and it represents the number of students who do yoga. That represents Y. We're going to use the Venn diagram to answer some simple questions. These are things that you might actually do one day or be interested in. So question A says, how many students like soccer? 15. 12 people like soccer, but 3 people like soccer and yoga, so it would be 15. Because you would include those 3 people as well, because they do like soccer. So the answer would be 12 plus 3. The answer would be 15. That's the number of people who like soccer. How many students then do yoga? It would be 10. You have 7 students who just do yoga, but you have 3 others who do yoga and they like soccer, but they still do yoga. So that means 7 plus 3, 10 students do yoga. C. How many students do yoga but don't like soccer? 7 people. If you look at your Venn diagram, you're looking for people who like yoga but don't like soccer. These 3 people who do yoga like soccer. These 7 people who do yoga, they don't like soccer, or else they would have been in the other group. So the answer now is 7. 7 people like yoga but don't like soccer? D, how many students like soccer and do yoga? 3. So that's asking you for the intersection. How many people like soccer and they like yoga? So Venn diagrams are a good way of figuring out quick information like that. If you did a survey of a whole bunch of people and you were like, who likes candy bars? And it's like you're trying to figure out a vending machine, what candy bars to put in. It would be like, all right, we got this many people like this, right? So you would be able to sort it out really quick by just looking at a picture rather than reading off your chart all the time. So Venn diagrams actually do get used a lot. And even in things like Microsoft Word or Microsoft Excel, there's like quick ways to make Venn diagrams off of data because that's an easy way to represent data. We're going to do one in here and see how well it goes. So, we're going to create a question based on people in this classroom who take English and people in here who take social studies. People in here who take both. So, question 1 is, how many students are in English this semester? So put your hand up if you're in English this semester. So we have 1, 2, 3, 4, 5, 6, 7. We have 8 people in English this semester. How many people are in social studies this semester? So hands up if you're in social studies. 1, 2, 3, 4, 5. How many people are in both social studies and English this semester? No, only 1. So 2. You would do both? Okay, I'm going to add the 2 results. So another 6. Can you put your hand up for both of these? Yeah? Okay, good. Well, we're adding you in. So we didn't have you in the original survey, but Brandon was helping us out. So if I went to make a Venn diagram that represented this data, I would make my universal set. I would make one bubble for people in English. I would label it E. And I would make one bubble for people in social studies and label it S. And I'm going to show you the trap that most people fall into. And they would go, I'm going to fill in this Venn diagram. How many people like or are in English? You might not like it, but you're in it. So how many people are in English? 9. How many people are in social? 6. How many people are in both? 3. So if you were to make this Venn diagram and you just plotted those things in like that, you would have made a really simple mistake. And what would that mistake be? Yeah, these 3 people I included in both groups. And if you think about it for a second, if we look in this room, how many people are in one or the other? How many people put their hand? Everyone is in English or social this semester, right? Is anyone not? Just you? Okay, so that means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 people in the class. If you look at our Venn diagram, how many people are in the class? More than 14. This would say that there's 18 people in the class. If you see something like that, that's how you know that you did not do your Venn diagram properly. So, the way to properly draw a Venn diagram once you have data is to always start from the inside and build out. So what we're going to do is we're going to start building our diagram by saying that there's 3 people in both. Now I can build the next circles. So, how many people are in English? Well, there's 9 in English, but I've already counted 3 of them, so I need 6 that are just in English. And you do the same thing for social studies. So you do the same thing for social studies. If you want to feel how many people are in social studies, well, you're going to say there was 6 people in social studies, but we've already counted 3 of them. That means there's 3 people in social studies. And somehow our survey didn't work out. Because that does not equal 12. So I don't know if we miscounted when we were looking around the room or something. Let's try it again. How many people are in English this semester? Let's see if we can do this. 1, 2, 3, 4, 5, 6, 7. You're in English this semester.
I think you counted you.
That's a lot. Yeah, no, but like, so you'd have your hand up right now. Because you're in English, and so would you would. That's what we messed up. So it'd be 1, 2, 3, 4, 5, 6, 7. Hand up if you're in English. 1, 2, 3, 4, 5, 6, 7, 8, and it'd be 9. How many are in social? 1, 2, 3, 4, 5, 6. How many are both? You and just you and? So those? Okay, that would be the difference. How does that? So when you build these Venn diagrams, build it from the inside to the outside. And we just messed up on our survey, which is why it didn't balance out properly. But that's okay. If you get a question on a test, you're not going to have to do a survey. You're just going to be given the data. Okay, I think we have one, a good example here. So we've got our 400 people. They were surveyed. It says 285 of them enjoy pizza, 320 of them enjoy muffins, and 63 people do not enjoy pizza or muffins. So this one's going to be a little bit tricky because it's telling us what people do not like. Question A says, how many people like pizza and muffins? So before we even draw the Venn diagram, we're going to see if we can answer this question. How many people like pizza and muffins? To do this, we're going to start with our universal set. How many people are in our universal set? 400 people were surveyed. And I'm going to get rid of the people who don't like pizza and don't like muffins. So how many people didn't like pizza or muffins? I'm going to subtract 63 people. And that's going to tell me that there's 337 people that are actually involved in this pizza muffin debacle. The other 63, they really don't matter to our survey. All right. Now, how many people are actually answering yes to pizza or muffins? How many people like pizza? We have 285 like pizza. How many people like muffins? So we're going to add that together, and we're going to figure out how many people said yes to one or the other of these questions. So if we add those numbers together, we should get 605, I think. 605 people answered yes to pizza or muffins. And we could use that information to help us fill in all three of these things. The way that we're going to do that is we're going to use some subtraction. Does anybody have any ideas what we're going to be subtracting from what? Give it a shot. You can't be wrong. So it's just, we're thinking out loud here. Yeah. So we want to take this number and subtract the total number of people that took the survey and said yes to one or the other. Let's try it. So if we take 605 and we subtract off 337, what does that give us? It should be 200 something. 268? Those 268 people are the people who said yes to both things. Because that's how many people you overcounted by. So that 268, that's going to be your middle section of your Venn diagram for per people. Because that's the people who like pizza and like muffins. When we go to create the rest of the Venn diagram, how am I going to figure out how many people like just pizza? I'm going to take the just pizza people, 285, and I'm going to subtract out the people who like both. And that should tell me how many people like just pizza. How many people like just pizza? Anyone got their calculator out?
17.
17 people like just pizza. How am I going to figure out how many people like just muffins? Same thing, yeah, but you're just using the muffin people. So 320 minus 268 equals 52. I trust you.
Just like muffins, not pizza.
I know, this survey is a little backwards. I think it's probably just the other way around, to be my guess. I mean, who doesn't like pizza? Vegans. Well, there's vegan pizza. Just harder to make.
Also vegan.
That is, yeah.
Like muffins are vegan.
They're not vegan? How come?
Yes.
Oh, that makes sense.
Vegan pizza's good. You're vegan enough, you're not.
I have a friend who's vegan and he never eats anything. He just always eats bananas and nuts. And every time I see him, he's just eating like trail mix that he's made on his own and then bananas. He eats so many things.
You're probably good for,
It's in good shape though. Yeah, I really hope so. Alright. That's the number of people who like both, the number of people who like muffins, and the number of people who like pizza. We missing something? We're missing 63 people. That's the people who didn't like either. And you need to include them in your universal set. So those people are on the outside. And if you did this properly, you should be able to add it up, and those numbers should equal your universal set. So if we go 63 plus 268 plus 17 plus 52, that's your 400 people included in your Venn diagram. So everyone is in the proper spot. Making Venn diagrams is a lot harder than reading. People tend to make a lot more mistakes at this part of the Venn diagram stuff because they don't know how to figure out the people in the middle section. So what we did was we took the people who like pizza or muffins, and then we subtracted out the number of people who were included in the survey to figure it all out. Okay, so that's the important part. Take the or and subtract out the total number of people who answered yes to either. And it'll tell you that middle section. I think that is the last thing. Yeah.